In this video, I wanted to help you guys practice finding values of the trig functions using the unit circle. What I have on the right is a copy of the unit circle that I've also posted on Blackboard as a separate item. It's not contained in the 8.2 well, there is an image of it in the 8.2 PowerPoint, but I've posted it as a separate PDF where it's a full page image, which is a good thing to print and have handy when you're doing all of the homework in Chapter 8. This skill, I mean, you're going to use it often in calculus too. You'll have a copy of this unit circle provided when you take the final exam. So whenever I ask you for trig values, I mean, that's the best way, is to look at the copy of the unit circle that I give to you to get these values. Okay, so I want to practice reading them. Starting with that first one, so sine of 11 pi over 6. So the first thing you do is find the position on the unit circle that corresponds to the given angle. So here's 11 pi over 6, and what we're really interested in are the x and y coordinates here. Now, since this problem is asking for the value of sine, remember that sine is the y value on the corresponding point on the unit circle. So sine of 11 pi over 6 is just equal to the y value that we see here, so negative 1/2. And so your answer is negative 1/2. Now, secant. So here you might have to think of this sort of in two steps. First, think of the reciprocal identity. Secant is the reciprocal of cosine. One way I've heard students remember this is that the s goes with the c. Secant is the reciprocal of cosine, and cosecant is the reciprocal of sine. So in each of those identities, one starts with c, one starts with s. Just one way to remember it. So secant's the reciprocal of cosine, which, remember, is the x-coordinate on the unit circle. So we could write 1 over the square root of 3 over 2, but rather than write 1 over a fraction, you might just think in your head, okay, reciprocal, so I just flip it, 2 over the square root of 3. With anything that you guys submit to me in writing, this answer is great. I don't think that rationalizing the denominator is always a good thing. It kind of depends what you're going to do with it, so I'm fine if you just leave it like that. If my math lab is instructing you to rationalize the denominator, remember that all you do then is multiply top and bottom by the square root of 3. So you could rewrite that as 2 square root of 3 over 3 when you multiply that square root times itself. And you might submit this answer over here in my math lab, but I don't know. Check the, they'll give you those instructions in blue below where you put your answer, so you can check that. But this answer is fine for me. Okay, number 3 that I have there, tangent of 11 pi over 6. So tangent, it's nice to think through, is sine over cosine. So in this case, sine of 11 pi over 6 over cosine of 11 pi over 6. That's y over x as far as that point on the unit circle. Okay, so I haven't left myself quite enough room, but let me see what I can do. So y is equal to negative 1/2 over x is equal to the square root of 3 over 2. Now, you don't want to leave an answer like that. That's too messy. It's called a complex fraction, remember, when there's a fraction within a fraction. But these are easy enough to reduce. We want to get rid of these inner fractions. So I want to get rid of these denominators, and they're both 2. Which is what makes this a little easier to simplify than some other problems. You can just multiply numerator and denominator by 2 here, so these cancel and these cancel. And our final answer is negative 1 over the square root of 3. Now, one thing about that, there is a shortcut to writing out the whole complex fraction and simplifying it. Tangents y over x. Notice that these are both over 2. So when these denominators are the same, and you're going to take a ratio, those denominators are always going to cancel. So when we think y over x, it's fine to just think straight to negative 1 over square root of 3 gives me this answer right here. You don't have to show this work. It's fine if you just think through that in your head. And we'll have a chance to do that in another example I've got set up here. Okay, here we go. Now I noticed in some of your homework they're going to give you negative angles. Something like negative pi over 2. Well, it's helpful to realize that pi over 2 radians is equal to 90 degrees. So 90 degrees, hopefully you picture in your head, I mean, that's a right angle. That's like the corner of a square. The negative angle tells us that we should go clockwise as opposed to counterclockwise. So negative pi over 2 radians is what I've drawn here in red, and it corresponds to this point on the unit circle. It's coterminal with 3 pi over 2. And so the xy coordinates that we use are the same that we would use if this were cosine of 3 pi over 2. When they're coterminal, they're going to have the same values for the trig functions. So anyway, negative pi over 2 corresponds to this point at 0, negative 1. And then you'd have to remember that, okay, cosine, that's the x coordinate. The x coordinate here is 0, so that's my answer. Now what about tangent of negative pi over 2? So that's, like we said, sine over cosine. Oops, this might get a little bit messy because I'm going to try to write it out quickly. Sine is the y coordinate, cosine is the x coordinate. So the y coordinate here is negative 1 over the x coordinate is 0. Okay, but whenever you divide by 0, that's undefined. So with any of these trig functions where you take a reciprocal or you take some kind of ratio, it's going to be possible that your denominator is 0, in which case the trig function is undefined. So your answer to number 5 there would be undefined. Okay, just a couple more here. And thank you if you're listening this far. Okay, so cotangent of negative 4 pi over 3. So we need an angle that corresponds to